So it's been a while since I've last done a video, and I just thought it's about time I did another one. So this is rotations and revolutions. Now I'm going to do something real quick. This first part here is just historical background. I'm not going to read that. Not necessary for what we're doing. So, this is a Ferris wheel. So the passenger capsule at the very top is 135 meters off the ground. That's the one right about there. And the diameter of the entire Ferris wheel is 120. That's the entire thing like that. Now the first question says, how far from the ground is the very bottom passenger capsule? Well, there's something funny here. This is essentially just saying, what is 135 minus 120? Because the very top is 135, the diameter is 120. So, subtracting that, we get that the very bottom capsule is actually 15 feet off the ground. So number 1 is 15. Now number 2, how far from the ground is the center of the Ferris wheel? And this one's a little tricky. So, I see people how they do this, and they actually try to take 135 and divide it by 2. Don't do that. That's just taking half from the top to the ground, which is actually about right there. What we want is right in here. So we take the diameter of 120, divide it by 2, and we get 60. Now we take this 15, because it's 15 feet off the ground. So 60 plus 15 is 75. So here, this is 75. Now this one is something that I see a lot of people struggling with. Now typically when you're used to hearing rotations and revolutions and stuff, you're used to seeing them on a coordinate plane. Now I made another video a while back, a couple years ago, that pretty much was actually just angles of rotation, not rotations revolution. They go hand in hand, but this is a little more complex. So I'm going to come out of here now. And, well, then again, if I make a mistake, I'm probably going to want to do this. Otherwise, it's going to start causing me to have to redo everything. Alright. So, assume there are 36 passenger capsules evenly spaced around the circumference, which is all the way around the Ferris wheel. Find the height from the ground of each of the numbered passenger capsules. Use the figure below to help you think of the problem. You only need to list the heights of positions 1 through 4. Which is that one, that one, that one, that one. Now once I get to number 2, I'm going to tell you something that I see a lot of people doing. I myself once made this mistake. Don't do it. It's not right. You don't get the right answers. So, there are 36 passengers around the circumference of the entire Ferris wheel. A circle has a full circumference, no matter what size or anything, of 360. You know, I'm actually surprised my penmanship isn't so bad. Because the last time I really posted a video was actually clear back in December of 2023, so it's been over a year since last actually done a video. So pay close attention to this part. So 360, now there's 36 passengers, so you do 36. Now 360 divided by 36 is actually just 10. So evenly spaced, each of these spokes are at 10 degrees. And you can actually double check yourself, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of these. Hold up. That's not right. It looks... That's interesting. Well, I guess makes sense. It's not gonna really be 90 degrees here, because if you look very closely, it's actually slightly that way here and slightly downward there. So there's 5 degrees leeway on each side. But that's not what we're solving here. So each of these spaces between these spokes, there and there and there, all down here, are actually 10 degrees. Now for position 1, here's what you're going to do. Is that we're going to want to find the sine of each of these angles. So we want to find angle 1. So it's this right here. Notice I drew a straight line. No, not there. Notice that I drew a straight line right here. I didn't round it off, I drew it straight. That's because we aren't finding the arc length, we're finding the vertical length. And that's where people go wrong sometimes. So, we found up here that the radius of this Ferris wheel is 60 degrees. So no matter what you're doing, this length right here, each of these spokes is going to be 60 feet. Now for the first one, this is 10 degrees. Put 10 there. Oh my gosh, see what I mean? Can't write. And then this is an X. Goodness gracious, so let's see what's going on here. I'm probably going to want to close this tab actually. Hopefully that'll speed my computer up just a little. Getting rid of about 300 megabytes of memory going on right now. Alright, so then we take this, so we take sine, nope, not that. So we take sine of 10, sine of 10, and then equals x over 60, x over 60. Now there's something fun you can do here. I love it when the variable's up top and the numbers on the bottom. It makes things so much easier. And you don't have to go through extensive steps. Because what you can do is to get rid of it, you just multiply both sides by 60. Because the opposite of division is multiplication. So that cancels. Notice I didn't cross out the x, just the 60s. We need the x still. And then this side also multiplies by 60. So then, essentially, we get 60 sine of 10. 60 sine of 10 equals x. Now, my calculator, now when you do this, make sure that your calculator is in degrees, not radians. If you do it in radians, it's going to give you the wrong answer. So, I'm going to go 60 sine of 10. And I get 10.41. Now it says to round it to the nearest tenth. So that'd just be 10.4 is x, but we're not done. We're not done. See, from the height of the ground of each passenger capsules, now we determined that the center of the Ferris wheel is 75 degrees. 75, oh my gosh, is this meters or feet? This is meters, okay. So that means it lined up there. So then there's this one, so it's slightly above. The point is, it's 75 feet off the ground, then plus the 10.4, which is 85.4. So plus 75 is equal to 85.4. Now, typically when you submit your stuff, you're going to want to make sure you do it and you do the measurements. But here it says do not fill in the measurements. Or at least, it doesn't say that, but it's just kind of a given because this program that I use, if you do measurements, there's a set answer. And if you do anything but that, it's going to give you a wrong answer, even if you do measurements or anything. So, alrighty. So that's 85.4. Now, I'm going to erase that. Don't worry. If you need this, you can always rewind. I might as well just erase this because I'm going to need this space for the next one. Alrighty. So for number 2, now there's something I see people doing, is that they take the 75 and the 10.4 and they think, oh, well, this is 10.4, so this must be 20.8. No, not true. It would be 20.8 if you were going like that. Oh my gosh. See, this is why I have such a hard time doing stuff. It would be 20.8 if you were going along like that, but we are going straight down like that. So, consequently, we cannot do that. We have to solve it through. So, that would be, so that would mean that 10 plus 10, we get a 20 right there. So I'm going to actually draw the triangle. So do that. And then that. Not to scale, by the way. So this is 20. No, I don't want to do that. This 60. And we're wanting to find x. Again. So, again, you know what? I'm getting tired of having to write. I'm just going to do it this way. So, we take sine of 20 is equal to x over 60. Now that is very small. You need to make that bigger so we can see that. Okay. So, now we want to cancel out 60. So multiply both sides by 60. And I'm just going to do this. I'm not going to worry about the parentheses because it's just, oh my gosh, I keep doing a right click. See, I use touchpads, but sometimes it can be a nuisance. So then we go 60 sine of 20. Now make sure, again, you are in radians or this will not work. Okay, so this one, you get 20.5. Notice the difference of the 20.8 that I got. This is 20.5212. Now, if you were to try to do this with the full of 10.41889, you get 10.41889. Let's just call it well, let's just do the full thing. I have right now. 0.66 times 2. You'd actually get 20.837783132. But I got 20.5212086. That 0.3 makes a big difference. So I get 20.5. So then 20.5, oh, come on. 20.5 plus 75. Yeah, I'm just writing just to write at this point. That is equal, no, I don't know, I want to do a division. Oh my gosh, load. Silly computer. Okay. And that is equal to 95.5. 95.5. No, not 5. I mean 4. I want 5. Yeah. See, it always takes a minute. One of these days I'm going to have to clear my cookies. 95.5. Now, so we get that one. Now people also try to do this, as they say, but notice that up here was 10.4, but this is a 10.1 difference. Because it's 10.4 plus 75, but then this is a 10.1 difference. So people say, oh, so to compensate for this loss, we just do and we just add 10.1 plus 10.1. Still does not work. Because with each increase, sign is different. Alright, so I think that we get the idea at this point. So I'm just going to do this now. Okay, I want a bigger eraser. I want it to just be big, so I can erase it a little quicker. Okay. So now this is 30 degrees. I'm going to show you why this will not work. So now it's getting a little, it's taking a while, so this is going, I'm just going to forget about explaining stuff, because it's just going to be 60 sine 30 is equal to x over 60, which just gets canceled out like that. So I'm going to make that a little bigger. So 60 sine of 30 is actually 30, believe it or not, which is really fun. It's an easy number. So 30 plus 75 is 105. Oh shoot, my calculator's almost dead. Okay, yes, I'll charge you when I'm done making this video. Hang in there. So that's 105. And 105 plane. Now, if you were to try to have done this with adding 10.1, you would have got 105.6. Anyway, so then number 4, we'll just do this again. This time, I'm just gonna do that. Get another line, just redo this. Just stick it in there. Slop it in there. Stoop it in there. 40. Okay, so stoop it in there. That's right. I always try to do the mouse cursor. You need the move cursor. So 40. So now that's 60 sine of 40 is equal to 38.5672568, which is just run to nearest tenth, 38.6. So that is 38.6. So then 38.6 plus 75 is 113.6. So 113.6. Now again, I'm going to show you. So if you got the 105.6, then you actually would have gotten 115.7 down here, which just goes to show again that they're just wrong. So now I'm just going to check these answers, make sure I did them all right, which I'm sure I did. So that one was correct. Yeah, very slow computer. Loading, loading, loading. There we go. Okay, check again for question 17, and then check question 18. Perfect. So those are all right. So I hope this video helped you to understand rotations and revolutions. And see you next time.